Hi everyone, today we're going to study geometric series. In science and engineering, we often write functions as infinite polynomials. For example, we have 1 plus x squared plus x cubed plus up to plus x raised to n plus and so on. We can write this in sigma notation like summation from n equals 0 up to infinity of the function x raised to n. Or we can write like this, summation from n equals 1 up to infinity of the function x raised to n minus 1. When the absolute value of x is less than 1, we can write the sum of these infinite polynomials, and it will be 1 over 1 minus x. For any value of x, we evaluate the polynomial as an infinite sum of constants, a sum we call an infinite series. Let's go to geometric series. A geometric series is the sum of an infinite number of terms that have a constant ratio between successive terms. We can write a plus a times r plus a times r squared plus a times r cubed plus and so on. The r here is the common ratio, and a, we can see that it is the first term. In sigma notation, we write summation from n equals 0 up to infinity of the function a multiplied by r raised to n. Take note that geometric series converges if the absolute value of r is less than 1, and diverges if the absolute value of r is greater than or equal to 1. Let's have example. Identify the first term and common ratio of the following geometric series. Also, determine if it converges or diverges. Let's start with problem A. Summation of n equals 0 up to infinity. The function is 5 multiplied by the quantity 1/2 is raised to n. Here, the first term, which is a, is equal to the number 5, while the common ratio, or r, is equal to 1/2. To test for convergent or divergent, we say that the absolute value of r is equal to the absolute value of 1/2. When we simplify, this is equal to 1/2, which is less than 1. Therefore, this series converges. Problem B, summation from n equals 1 up to infinity. The function is 2 multiplied by the quantity negative 2/3, and this is raised to n minus 1. The first term is a, and that is equal to 2. And the common ratio r is equal to negative 2/3. To test for convergent or divergent, we say that the absolute value of r is equal to the absolute value of negative 2/3. Simplifying this, we have positive 2/3. And this 2/3 is less than 1. So we say that the series converges. Problem C. Summation from n equals 1 up to infinity of the function 3 times the quantity 7 is raised to n minus 1. The first term a is equal to 3, and the common ratio r equals 7. Testing for convergent or divergent, we say that absolute value of r equals the absolute value of 7. Therefore, this is equal to 7. And we can see that 7 is more than 1. Therefore, this series diverges. Today, we're going to study sum of geometric series. Given a geometric series, summation from n equals 0 up to infinity of the function a times r raised to n. If the absolute value of r, or the common ratio, is less than 1, then the series converges. And the summation from n equals 0 up to infinity of the function a times r raised to n equals a over 1 minus r. Remember, a is the first term and r is the common ratio. Let us see this example. Determine whether the following geometric series are convergent or divergent. If convergent, find the sum. We have two sample problems here. Let's begin with problem A. Summation from n equals 1 up to infinity of the function 5 times the quantity 1/2 is raised to n minus 1. Collecting the values, a equals 5 and r is 1/2. The absolute value of r, we can write absolute value of 1/2. And the value here is equal to positive 1/2. We can see that this is less than 1. So we say that the series is convergent. Since this is convergent, we can use the formula for the sum. A over 1 minus r. Substituting the values, we have 5 over 1 minus 1/2. Simplifying the denominator, it will be 1/2. So 5 over 1/2 is equal to 10. This is the final answer. Now, problem B. Collecting the values, a equals 2 and r equals negative 1/3. The absolute value of r is equal to absolute value of negative 1/3. And this is equal to positive 1/3. And 1/3 is less than 1. So we say that the series is convergent. We can use the formula for the sum. Let us now substitute the values. The a becomes 2 all over 1 minus the r is negative 1/3. Negative and negative becomes positive. So 1 plus 1/3 becomes 4/3. And this complex fraction, we can show that 2 multiplied by 3 over 4. And this will be simplified into 3/2. This is the final answer. I hope you learned something from this video. See you again next time.